the message will be blocked as 64-bit, whatever may be the size of the message. One of the cipher that is a block cipher is a play-fair cipher. The key set can have multiple values. Key may have single value or set of values. This data encryption standard is a symmetric key block cipher. That means the encryption is done block by block. Hello students, welcome to the next session of Network Security. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram College. In this session, I am going to tell you about some concepts of the stream and block ciphers which were started in the last session, and something about the data encryption standard. Alright, the stream and block ciphers is nothing but categorizing the different types of traditional symmetric key ciphers that were explained in the previous sessions. Alright, here what are the different categories that come under stream ciphers, and there are some ciphers that come under the category of block ciphers. You know about stream and block ciphers, isn't it? In this session, I'll tell you about the block ciphers. Alright. In the block ciphers, group of plain text symbols are used which are of size M. M may be varying size but must be greater than 1. Alright. Are encrypted together. In stream cipher, all the characters are taken at a time and are encrypted. But in block ciphers, group of plain text, not the entire plain text, group of plain text will be taken and encrypted together, creating group of cipher text, not the entire cipher text. Group of cipher text will be obtained by creating a block of same size. What is the size of the plain text? Will be the size of the cipher text. Alright. Sometimes a single key is used to encrypt the whole block, even if the key is made of multiple values. There will be single key that will be applied for all the blocks of the plain text, even though the key set can have multiple values. Key may have single value or set of values, but it will be same for all the blocks in the plain text. Okay. Here we have the representation of the block cipher where the word plain text is divided into blocks of 3 characters, where you can use a set of key INT. This is an example 1. You can use the key INT which will be applied for either for BLA or INT or EXT. For all the 3 blocks, same key set will be applied which gets the cipher text SOD, that is D will be encrypted as I, P will be as N, V will be as T. Okay, so that will be encrypted like this. Okay, P encrypted as S, L encrypted as O, A encrypted as D, like this. Same key set will be used for encryption as well as decryption. Alright. This is block cipher. If you look at the examples of block cipher, one of the cipher that is a block cipher is a play-fair cipher. Okay, play-fair cipher is applied on block of characters. Okay, the size of the block will usually be two sets of text will be taken, plain text, and are used and are encrypted using the matrix of characters. You can review the previous videos. 2 characters will be encrypted. This is an example of block cipher. Another example, if you take, it is the hill cipher. Okay, hill cipher again are one of the block cipher. A block of plain text of size 2 or more can be used to perform the encryption operation using again a single key. Even the hill cipher uses the matrix to encrypt the characters. In these kinds of ciphers, the value of each character in the plain text depends on all the values of characters in the plain text. So, based on the character, the encryption will be done. Although the key is made of M cross M matrix, it is considered as a single key because it uses the single matrix or single character to encrypt. It is called or considered as the single key only. Okay. If you take the next example, we have the next example. Every block cipher is a polyalphabetic cipher because key or key set will always have different characters in the key which takes different value for different same character. Maybe different or same based on the position. The encrypted character or the ciphertext character will change. Okay. From the definition of the block cipher, we can conclude that every block cipher is a polyalphabetic cipher. Why? Because each character in the ciphertext block depends on all the characters in the plain text. You cannot skip any text or character in the plain text. It depends on the entire text in each of the block. Okay. Next, you have the combination of the stream and the block ciphers. What does the combination suggest is blocks of plain text are encrypted individually. It is not done at a time. All the threes are used and converted. In a block, each character is considered, but they use stream of keys, set of keys or same stream of keys is used. As you see in the example, diagrammatic example. So DPV, this INT, DPV is used, same difference or additive method is used for all the characters. It is not changed. It is stream wise, isn't it? If we use DPV here, same is applied for PLA. Order is not changed. If you are having DPV for INT, okay, key set here we have is 4, 2, that is I, D, E, F, G, H, I. There is 4 value difference, 4 character difference. P, M, N, O, P. So there will be only 1 character difference. Again, T, U, V. Again, 1 character difference. So we have character difference. So this order will be maintained throughout the available blocks. So a stream of keys are used to encrypt the whole message block by block. That means stream method is used in block ciphers. When you look at the stream ciphers, the cipher is a block cipher when looking at the individual blocks. When you look at the individual blocks, it is a block cipher. But it is a stream cipher when looking at the whole message. When you look at the whole message, block is encrypted in a same order. That means order has not been changed. It is in a stream-wise manner. Okay. each block as a single unit. If you consider each block as single character, it will be a stream cipher. When you consider a individual block, it will be a block cipher. Okay, you can have the method of both the stream and the block ciphers in the traditional method. Okay, now let's move on to the modern key ciphers. Till now, we have studied about the traditional key ciphers, different methods of traditional key ciphers, how they are going to use the traditional method. Now, let's have a look at the modern key ciphers. One of the modern key ciphers that are used is the DES, or the Data Encryption Standard. Okay, this Data Encryption Standard is a symmetric key block cipher. That means the encryption is done block by block. It is a symmetric key block cipher which was published by the National Institute of Standards and Technology. This is a standard ciphering method that is used in modern encryption method. Okay, this is the most popular one. It was published in 1973 by NIST. It published a request of proposals for a national symmetric key crypto system. Okay, there were so many methods that were used, but there was no unified method that are used to encrypt a message, or there were no encryption standard that were used to encrypt a message. But from the usage of our proposal of the data encryption standard, we got a particular method of encrypting the data using the data encryption standard. All right. Even a proposal from IBM, a modification of a project called Lucifer, was accepted as the data encryption standard. It was not entirely new, but was already proposed by the IBM, which was then with little modification was accepted as the data encryption standard. All right. The data encryption standard was published in the Federal Register, okay, in the year 1975. In 73, it published the proposal and a little modification was made from the IBM's suggestion, and the actual DES was published in the year 1975 as a draft of the Federal Information Processing Standard. Okay, this is all about the history of the data encryption standard. The overview of the data encryption standard shows that the key they are using is a 56-bit key for a 64-bit plain text. Okay, plain text is of 64-bit, whereas key is of 56 bits, and it is encrypted into the 64-bit ciphertext, and the reverse is, there will be a reverse cipher method where the 64-bit ciphertext is decrypted into the 64-bit plain text. All right, how they are going to perform this cipher method? Let's have a look at that. Okay, before looking at how does the encryption and decryption can be done, we shall look at the structure of the data encryption standard. Okay, the encryption process is made of two permutations. That means there will be permutations of the text, that the text will be replacing or changing the position, okay, based on two permutations. There will be two permutations that will be carried out, which can be termed as the initial and the final permutations. There will be initial permutation and a final permutation and 16 fizzle rounds. There will be 16 times permutation of characters so that the attacker will find it difficult to analyze the cipher text and decrypt it. So, there will be an initial permutation and a final permutation. Between these initial and final permutation, there will be 16 fizzle rounds. That means there will be 16 times permutation of the initial combination of the characters. Alright, each round uses a different 48-bit round key. There will be a 48-bit round key that will be generated from cipher key. There will be a single cipher key for each round. So, 16 round uses different 48-bit round key. There will be 48-bit round key means if you have extra text in the plain text or extra characters, the key starts with the first character. Like if it is A to Z, next characters you have, again it starts with A. Like this, the 48-bit round key will be generated for each round, but uses only the one set of key values. Okay, here we have the representation of structure of the DES. Okay, there will be a 64-bit plain text. For 64-bit plain text, a 56-bit cipher key is applied, but not all the 56-bit is applied. Instead, in that 56, a set of 48-bit is used as first key for first round. Before first round, there will be an initial permutation done on the set of plain text. Okay, there will be initial permutation done. On that initial permutation, first round of encryption is done using the 48-bit key. Okay, in the next round, another 48-bit key is used from the 56-bit cipher key. In the same way, up to round 16 permutations will be done from this 56-bit key. Any permutation, any method can be used to permutate. Once the round 16 is finished, the final permutation will be done, which gives you a 64-bit of cipher text. Alright, this is the structure of the data encryption standard. Alright, now we have the diagrammatic representation of this initial and final permutation. You can observe here the first character is permuted for 40th character. This is the initial permutation. And second character is permuted for 8th position and 58th is permutated for first position. And lastly, the 64-bit is permutated for 25th position. There will be change in the position of each of the character in the 64-bit plain text. Okay, this is the initial permutation. For this, 1, 2, 8, 25, 40, 58 and 64. Positions are same, but the characters will be changed. Position of the character will be changed. Okay, and 16 rounds of fizzle rounds will be applied with 56-bit key and uses the permutation of 48-bit. Okay, when it comes to the final position, again the final permutation is done. The first character is permutated back to the 58th position, whereas the 40th character is permutated to the first position, okay, which gives you the cipher text, okay. The entire process has 3 steps. The initial permutation, 16 Fessel rounds and final permutation. All right. So this is the structure of or the process of getting a cipher text in the DES. All right. Each of these permutations, okay, takes a 64-bit input. There will be, the message will be blocked as 64-bit, whatever may be the size of the message. Entire message is split into blocks of 64-bit. As I said, DES is a symmetric key block cipher. That means block of plain text will be given for the algorithm to obtain a cipher text. Okay, 64-bit input data will be given and permutes them according to a predefined rule. How it must be permutated? Whether it is randomly done, it's not randomly done. The rule will be predetermined. Based on the predetermined rule, the permutation, the initial permutation will be done. All right. We have shown only the few input ports, not the entire input port has been shown here. Some of the permutations has been taken as an example. Okay. Only a few input ports have been shown and the corresponding output ports. Okay, not everything has been shown. Okay, these permutations are keyless. Permutations doesn't use any key. There will be a predetermined rule. Based on that, the permutation will be done, but key will be used only in the Fessel rounds. Okay, straight permutations that are inverse of each other. The initial and the final permutations are inverse of each other. They are not doing in the same way, but in the reverse order. Whatever the initial permutations has done, permutation, the final permutation will do exactly the reverse of the initial permutation, but both are keyless procedures. All right. In the next session, we shall continue with the more concept of the data encryption standard. All right. Thank you.